Welcome back guys to another video discussing parabolas. So for this video, we're going to discuss the elements of a parabola. So we're going to discuss the first three elements of the parabola. Namely, the vertex, the axis of symmetry, and the focal distance. So the first element is the vertex. Okay, so how do we define the vertex? So the vertex is the point where the parabola crosses its axis of symmetry. Okay, so next, it's the extreme point of the parabola. We're going to discuss what does an extreme point mean. Okay, so next, the point where the parabola changes the direction. Next, the point halfway between the focus and the directrix. And we have the notation V, capital letter V, HK, where our H is the horizontal movement from the origin, and K is the vertical movement from the origin. Okay, so why is it called the point where the parabola crosses its axis of symmetry? Okay, so one thing to take note is that the axis of symmetry, the axis of symmetry is actually the line. It's a line. Axes are lines, okay, where our parabola is mirrored or mirrored out, or it becomes a mirror image. Okay, so for example here, this is a parabola opening upward, so the axis of symmetry is this line here, because the mirror image of this part here, so the left part and the right part, okay, so is defined by this line here. So now, it's the point where the parabola crosses its axis of symmetry. So as you can see, the point here, this one here, okay, is the vertex. Okay, or in other words, we can define this one as the starting point. It's the starting point of the parabola. Okay, next, it's an extreme point of the parabola. When we talk about extreme, we're dealing with the concept of maximum and minimum. Again, extreme, it's maximum or minimum. Okay, especially when it's actually facing or opening upward or downward. Okay, so in this case, our vertex is the minimum point because it's the lowest point of the graph. See, if you try to trace out, VHK is the lowest point. Next, it's the point where the parabola changes direction. Of course, it's like a pin. Okay, just imagine a pin, the thing that you use in your what do you call this, when you try to pin some paper. So the pin, so VX is the vertex is like a pin, so it's pinned down. So if it changes, okay, if it changes going downward, so the pin never changes, it's just there. Okay, so it's the turning point. Sometimes we call this one as the turning point. Okay, next, the point halfway between the focus and the directrix. Of course, if you try to go back in our last video, so we have the, what do we call this, the focus, of course. So if it's opening upward, the focus is above. So let's say the focus is somewhere here. Okay, then the directrix is somewhere here. So the directrix is this black line here. Okay, so the vertex is halfway from the focus and halfway from the vertex, from the directrix. Okay, sorry, directrix. So remember that in this point here, okay, this point from the this is the focus, this is the vertex, and vertex to our directrix. If you try to observe, our V becomes the locus. Okay, V is also a locus of the parabola. Hence, the distance are all equal. So it's like this is F, this is P, then this is P, then this is D. Okay, so the distances are equal. That's why it's halfway, because if you try to divide it by 2, remember there are two parts here. You try to divide by 2, it will give you the distance of the vertex to the focus, or the distance of the vertex to the directrix, the perpendicular distance. Okay, then of course notation VHK. Now, why we say horizontal movement from the origin? What is the origin? Yes, you're right. The origin is 0, 0. It's a point. Okay, so the origin is here, somewhere here. Okay, it's here. So this is 0, 0. Okay, now the HK here defines the movement of our vertex with respect to the origin. So in this scenario, this is H, the horizontal part, this is H away from 0, and this is K away, so constant K away from the 0 value on the Y value, okay, or the vertical movement from the origin. So that's our vertex. Next, we have the axis of symmetry. So from the term symmetry again, it creates the mirror image. Okay, so the dashed blue line here, that's the axis of symmetry. So as you can see, it's a line connecting the vertex and the focus, which divides the parabola into two equal halves. So remember, the focus here lies at the axis of symmetry. The vertex also lies at the axis of symmetry. And in fact, the axis intersects the directrix, okay, or the fixed line directrix. So we have the two notations here. X equals h whenever the parabola is opening upwards or downwards. So in this case, this is opening upwards. Our axis of symmetry is h. X equals h. Okay. If it's left to the left and right, or left or right, opening left or right, it's y equals k. Lastly, we have the focal distance, also called the focal length. So this is the distance from the origin to the focus and from the origin to the directrix. So we need to take note that we always take the absolute value because distance is positive. So our notation is p. Okay, so in layman's term, it's just a distance. And this distance refers to the distance that we have discussed a while ago in the vertex. So p here is actually this part here. And remember, since these two here is equal, or are equal, so this is also p. Okay, so that's the focal distance. So this is called the focal distance for the reason that it's the distance from the vertex to the focus.